Problem solving, unit conversions. There are going to be word problems, math word problems in this class. There's going to be a bunch of them. How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. Okay? That makes absolutely no sense, does it? And a lot of people have the impression that they do not understand math, that they cannot understand word problems, and you kind of have this helplessness about that. I can teach you how to do word problems. It's not, I can't just magically, inject something into your brain. But if you'll work with me and ask me questions, I can show you how to solve word problems. And once you get it, it's just an amazing experience. So hopefully this will not be true by the end of the class. When we're looking at a word problem, we've got this problem statement, Johnny was on a train going 5 miles an hour north, and Susie was coming on a bus 37 miles per hour south, and they crashed, and things like that. Those are the word problems we're talking about. We have to have some critical thinking skills. We can't expect that we're going to read the problem and immediately know what to do. We can't expect that. We're going to have to think about it. We might have to just sort of puzzle about it and pull it apart. We have to have some critical thinking skills. I cannot give you a simple formula that will apply to every problem that you're going to run into. But we can have an approach, and we can learn problem-solving strategies so that we can deal with problems that we haven't seen before. Many problems that we encounter can be thought of as unit conversion problems. It's really just a matter of we're given this thing with these units, and then we have to figure out what that quantity is in these other units. And this comes up a lot in chemistry. There are other problems that require the use of either a specific equation, or you may need to use algebra and rearrange that equation. So these word problems fall basically into 2 categories: unit conversion problems and equation/algebra problems. We need to learn how to convert between units. I think the most important thing I learned in high school was how to do unit conversions. It was my physics teacher, junior year, taught us a technique called dimensional analysis, and using that you can actually bluff your way through most of physics. All the calculations and stuff, if you know how to manipulate the units, you can figure out how to do the problems. It's an awesome thing. And it works wonders in everyday life as well. Units can be thought of like variables in algebra. They can be multiplied and divided, added and subtracted, canceled out, raised to powers, just like x's and y's. Okay? So they can cancel out. And dimensional analysis is where we use the units as a guide to solving problems. Dimensional analysis, we analyze the dimensions, we analyze the units, sometimes called unit analysis. So really important, always write every number with its associated unit. Now the things we're going to be doing are not as important as building that orbiter to go around Mars, but leaving out the units can still have negative consequences, like getting an answer wrong on an exam. Even though you understood the concepts, you failed to write down a unit and overlooked a conversion that needed to happen. Always include your units in your calculation. Do not let the units magically appear or disappear. They're like algebra variables. If they're there at the beginning, they're going to be there at the end. Carry them through. A number without a unit is naked, okay? And we don't want any nudity in class, okay? So for most conversion problems, we've got a quantity that's given to us in one unit, and we're asked to convert that to a different unit. And so these calculations are going to take this general form. We've got the information that's given. We're going to multiply by one or more conversion factors, and then we're going to get the information that we're trying to find. So the given unit times a conversion factor that relates the unit we want to the given unit, and then we end up with the desired unit. So how do we make those conversion factors? We make conversion factors from two quantities that are known to be equal. So some of these are found in tables. Here's an example, a table from your book. This tells us that 1 kilometer is equal to 0.6214 miles. 1 inch is equal to 2.54 centimeters. 1 liter is equal to 1.057 quarts. Those are equivalence statements, and we can use those to create our conversion factors. Other conversion factors arise just from the use of those metric prefixes that we talked about. So let's construct conversion factors relating feet and inches. Well, what do we know about the relationship between feet and inches? 12 inches equals 1 foot, right? That's one that I expect people will know. 12 inches equals 1 foot. Well, what would happen if we divided both sides of this by 12 inches? Would it still be equal? If you take an equality and you do the same thing to both sides, is it still equal? Yes. Yes, it is. It's just like taking a balanced teeter-totter. And maybe you've got two kids that weigh the same and they've got it perfectly balanced. And you hand this one a 10-pound bowling ball, and you hand the other one a 10-pound bowling ball. You did the same thing to both sides. Is it still balanced? Yes, it is. This is an important idea about math equations. What does 12 inches divided by 12 inches equal? 1. So that means that 1 foot divided by 12 inches is numerically equal to 1. You believe it? That's a conversion factor. We take the equivalent statement, we divide by one of the quantities on both sides, and then here is our conversion factor right there. It is numerically equal to 1. So if I take 36 inches and I multiply by this, 1 foot divided by 12 inches, I am multiplying by 1. Am I changing the length? No. But what does this end up being? 3 feet. See what happens with the units here? Inches divided by inches. They act like variables, like x's. X divided by x is 1, right? Inch divided by inch is 1. We say they cancel out. The unit that's left is feet. And there I've converted 36 inches into feet. 36 inches is equal to 3 feet, right? Something like that you can probably do in your head because you understand inches and feet. It's important to learn this technique, though, so that we can do this with things that we are not familiar with, like the mass of hydrogen related to the number of moles of oxygen in a chemical reaction. That's one that's not intuitively obvious. Let's look at inches and centimeters. 1 inch is how many centimeters? 2.54 centimeters. That's a good one to memorize because it comes up a lot. There are 2 conversion factors that can arise from any of these. If we divide by 1 inch on both sides, we get this factor. What would happen if we turned that upside down? Is that still equal to 1? Yeah, because if you take 1 and you invert it, turn it upside down, it's still 1. So there are 2 conversion factors relating any 2 units. You can put either unit on top. And I think we're out of time, aren't we? We're supposed to end at 9:25? Yeah. So we'll stop there.